Every program begins as a stream of ideas, a sequence of steps, a flow of logic that moves from one thought to the next. At first, everything feels simple. You write a few lines. You solve a small problem. You move on. But as your program grows, repetition appears. You start writing the same instructions again and again. You copy. You paste. You repeat. Humans don't enjoy repeating themselves. We want clarity. We want structure. We want to express an idea once and reuse it many times. Machines don't mind repetition. They can repeat a task forever. But Python gives you something better than endless repetition. It gives you a way to package logic, to compress thought, to build little machines inside your code. These machines are called functions. And once you start using them, your programs become cleaner, smarter, and easier to grow. A function is not just a block of code. It is a tool, a small, self-contained engine that performs one job. Think of your program as a workshop. Variables are your materials. Loops are your conveyor belts. But functions are the machines you build inside that workshop. You give each machine a name. You define its behavior. You decide what goes in, and you decide what comes out. A function is a promise. It says, whenever you call me, I will do this exact thing. It doesn't get tired. It doesn't forget. It doesn't change its mind. It simply follows the blueprint you gave it. This reliability is what makes functions powerful. They turn your code into a collection of reusable ideas. Every function begins with a blueprint. Def is Python's way of saying, I'm about to describe a machine. The name is the label on the machine. It tells you what the machine does. The parentheses define what the machine accepts. Sometimes they are empty. Sometimes they contain parameters. The indented block is the heart of the machine. It contains the instructions that run when the machine is activated. Python keeps this structure simple, readable, human. You don't need symbols or complex syntax. Just a clear declaration of what your machine does. Defining a function builds the machine, but a machine that never runs is just decoration. To activate it, you call it. When you call a function, Python jumps into it. It steps inside the machine. It follows the instructions you wrote. Then it returns to where it left off. A function call is a controlled detour, a temporary jump in the timeline of your program. You leave the main path, perform a task, and return. This ability to jump in and out of logic makes your code modular and clean. Machines become more useful when they accept input. A blender without ingredients is just noise. A camera without a subject is just a lens. Functions are the same. Take a look at this code. Here, name is a parameter, is a placeholder that waits for a value. When you call the function, the machine now has context. It adapts. It responds. It personalizes its behavior. Parameters turn functions into flexible tools. They allow your machines to handle variations. They allow your code to respond to different situations. Without parameters, your functions are static. With parameters, they become dynamic and expressive. Some machines don't just perform actions. They produce results. Return is Python's way of handing something back. A value, a result, a conclusion. Without return, a function performs actions but doesn't create something you can use. With return, the function becomes a generator of answers. This distinction shapes how you design your code. Some functions act. Some functions compute. Some do both. But the moment you use return, your function becomes a source of truth. It transforms input into output. Every function has boundaries, invisible walls that define its private world. Variables created inside a function stay inside it. They live and die within its walls. They don't leak out. They don't interfere with the rest of your program. This is scope. Scope prevents conflicts. It protects your logic. It ensures that one machine's internal details don't collide with another's. Imagine a factory where every machine has its own workspace. Tools don't get mixed up. Parts don't get misplaced. Each machine operates independently. That is what scope gives you. A guarantee of safety and clarity. Functions are not just tools. They are building blocks. You can combine them, layer them, chain them together to form larger systems. A small function handles a small task. A larger function orchestrates smaller ones. Your program becomes a hierarchy of machines, a factory of logic. This is how complex software is built. Not through giant blocks of code, but through small, reusable pieces that work together. A function that calculates a price. A function that formats a message. A function that sends an email. A function that logs the result. Each one is simple, but together they form a system. Functions make your code cleaner, clearer, more organized. They reduce repetition. They increase readability. They turn chaos into structure. But more importantly, they let you think at a higher level. Instead of focusing on how something works, you focus on what it should do. You stop thinking about the gears. You start thinking about the machine. Functions free your mind. They let you build ideas, not just instructions. They turn your program into a system of reusable thoughts. They are the little machines that power every Python program. Thanks for watching, and I'll see you in the next chapter of this digital adventure.